Students in Latin America are lagging on average 5 years behind global standards, and solving this requires more than just an AI chatbot.
The real problem is that kids are not motivated. They don't even believe that they can learn math. So the question is, how can we reach those kids? The ones that are sitting at the back of the classroom, just waiting for the bell to ring. Even Khan Academy recognized this after years of pushing their AI tutor.
And we understand this perfectly because we don't just come from building apps. But 5 years ago, we founded a private K 12 school with two ideas in mind. We need a caring adult to motivate the student, and we need teaching at the right level. Turns out families love this, and we currently have more than 200 students enrolled. But now, our goal is to build the technology and tools to reach millions of kids across the region.
Last quarter, we designed our methodology to accelerate learning in remedial students, where we propose to use AI to assess students and provide a personalized curriculum. We suggest to build confidence through meaningful relationships, guiding parents on how to support their own kids. And finally, we promoted consistent practice by building a virtual world where kids can engage and level up by completing lessons.
This quarter, we turned our proposed methodology into a theory of change that could guide our experiments and learning. With this, we developed two hypotheses. The first one is that we can guide parents to improve their child's motivation. And the second one is that we can use AI to help students learn faster.
For the first hypothesis, we started by identifying the traits that were correlated to academic achievement. Based on that research, we created our own simplified surveys, one for students and one for parents.
We applied this survey to 30 families and did a quick assessment on its validity by matching its results to the students' academic scores. Fortunately, it was directionally consistent with what we would expect from literature.
These 30 families participated in a WhatsApp group with weekly video lessons and activities. And at the end of the 4 weeks, we did a group call to share feedback, and families took the survey again as a post test.
During the group calls, we received a positive qualitative feedback. Parents especially appreciated our guidance on how to improve autonomy, even in cases where the students had autism. But our biggest challenge was handling retention. Only 10 families remained engaged after 1 month. And this affected our ability to measure impact. However, we were able to see some positive changes. For example, we saw a reduction in controlling parenting style by zero point 0.7 standard deviations, and both academic socialization and academic anxiety improved by half a standard deviation, but other traits had no measurable change.
Going back to our hypothesis, we observed that autonomy support was the best way for parents to improve motivation and academic achievement. And we managed to get improvement on some traits, but haven't yet observed a direct increase in autonomy support, which was our main goal.
But after seeing how predictive some of these traits are to the student's progress, we believe that this is a challenge that is complex but very worth it.
We then tried to answer our second hypothesis, testing if students can learn faster with AI. So for our pretest, we took Mexico's national curriculum and designed hundreds of assessment items to build an adaptive test. Then, 25 students took the test to identify and measure missing skills.
Then they engage in a Socratic dialogue with an AI tutor. We design a conversation flow that helps them understand the problem, plan a strategy, follow a step by step process, and review their knowledge. However, when we measured the results, we only got a mean learning gain of 2.5%.
We decided to change our approach, and instead of using the AI chat as a means to deliver content, we used it to get a deeper diagnosis. We analyzed the conversation to extract the misconceptions and blockers to mastery of the skill. And with this context, we generate a 15-minute lesson that's tailored to the student's learning needs.
We apply a post test 2 days later, and the results were drastically different. Test results increased from 26% to 66%, showing a 40% mean learning gain. More than half of the students got significant improvement, and 4 students even went from 0% to 100% in their scores.
So, regarding our second hypothesis, we conclude that kids in fact learn much faster, not when using AI to teach, but when we use it to get a deeper diagnosis. We are leveraging our existing school as a lab to build new technology and provide long term sustainability to our development. But this quarter, we realized that if we want to change education in Latin America, we need other schools to implement our methodology. So we're going to follow a B2B model. Schools know that they need to change in the AI era, and being at Stanford, we are on a great position to lead this change in our region.
This model has already been proven in India, where Lead School is serving 8,500 schools and 5 million students. They are targeting affordable private schools just like us, and the market conditions in Latin America are very similar.
There's a difference, though, in market opportunity, where India has a larger population, but Latin America has a larger market in terms of purchasing power. That's why we believe that this is the right moment to build a similar model for our region.
3 months ago, we won the first phase of the Learning Design Challenge. And this allows us to build the tools for diagnostic academic placement, but also motivation of the student. We built a parent engagement program and an adaptive learning app.
During the next phase, we will iterate and improve these tools to run a larger pilot to gather more data.
And we're looking for advisors and impact investors. So if you also want to change education in Latin America, we'll be happy to talk.